In this video, we begin to look at the word problems from the end of Chapter 1, Section 2, Solving Multi-Step Equations. And example 16, or exercise 16, is an example of a very common type of word problem that shows up in algebra. And it goes like this. A repair bill for your car is $553. So if we're translating as we go along, we know that the total is going to come out to be $553. So if we write that over here as our total. The parts cost $265. Now it doesn't tell us how many parts there are, but it does tell us that the total for all of the parts was $265. Sorry about that. So we do know that the total for all of the parts was $265. In addition to the parts, we have a labor cost. And the labor cost is going to be $48 per hour. So this is one of our crucial phrases when we're working with word problems. Per hour, which means for every hour of service that is required to install the new parts, we're going to have to pay $48. How many hours will there be? Well, that's exactly what we're trying to figure out. The last sentence says, write and solve an equation to find the number of hours of labor spent repairing the car. So we know that. We have $48, or we will have $48 for each hour that we spend, or that is spent, repairing the car. So now we have this multi-step equation, and we're going to solve it using the strategies that we've talked about throughout this section. Since there is nothing to distribute, there is nothing to simplify before we begin, we can start with addition and subtraction. We end up with 48x is equal to 288. That 48 times x is 288 is going to be the cost, the total labor cost, which we will then add, to which we will add 265 for the parts and give us the total of 553. But to find the number of hours, we're going to take the labor cost and divide it by $48, and we'll end up with 6 hours. So the workers would have spent 6 hours of labor putting in the new parts, and so we have the parts cost plus the labor cost is equal to the total cost. That's the basic structure of this problem, and the labor cost, remembering that it is a variable cost based on the number of hours that are spent doing the repairs. Let's go on to the next example. In the next two problems, 25 and 26, we have these geometric examples where we are working with the sum of angle measures in a triangle first and in a quadrilateral second. Now we're told that, but many of us already know, that the sum of angle measures in a triangle has to add up to be 180. The sum of angle measures in a quadrilateral has to add up to be 360. So we're simply going to then use an equation. We know that all the angles in the triangle, first of all, which would be 45. So this is example 25 here, and the previous was example 16. So we have 45 degrees plus 2k degrees plus k degrees has to come out to equal 180 degrees. So here we begin with simplifying, combining like terms. We have 45 plus 3k is equal to 180. Subtracting 45 on both sides leaves us with 3k is equal to 135. Dividing both sides by 3, we end up with k has to be 45 degrees. However, we're not asked what K is in this problem, we're asked to find the angle measures. So in the first, the triangle, our angle measures are 45, and then 2 times K, which is going to be 2K is equal to 90 degrees, and then K is equal to 45 degrees. In problem number 26, similar example, only this time the sum of angle measures has to be 360 degrees. So number 26, we'll start with the equation 2a plus 2a plus a is equal to 360. We're going to combine like terms. We have 2a, 1a, 2a, 1a, which gives us 6a is equal to 360 degrees. Dividing both sides by 6, we get that a is equal to 60 degrees. So the sum of angle measures are 2a is going to equal 120 degrees. A is equal to 60 degrees, and so we can list the others. 2a is 120, and a is equal to 60 degrees. Okay, so again, if you need to review any of those, you can rewind, replay, etc. I'm going to scroll down and look at the next exercise. An example or exercise 35. During the summer, you work 30 hours per week at a gas station and earn $8.75. You also work as a landscaper for $11 per hour. So there's our key phrase, $11 per hour. Well, the sentence above also uses per twice. 30 hours per week. So we're not sure if we're trying to figure out how many weeks. And it says $8 and at a gas station, and you earn $8.75 per hour. But here we're not trying to figure out how many weeks you worked at the gas station, nor how many hours you worked at the gas station. We're told you worked 30 times 30 hours for $8.75 per hour. And so if we were to multiply those out, we'd get $262.50. What is that? That is your earnings for 30 hours work at the gas station. Alright, so you also worked as a landscaper for $11 per hour, and you can work as many hours as you want. So here we don't know how many hours, so we're going to use a variable to represent the number of hours that you worked as a landscaper, and you know that you want to earn a total of $400 per week. So the basic structure of this problem is your gas station earnings plus your landscaping earnings is your total earnings. So we know from the problem that you made $262.50 from the gas station. You also earn $11 per hour for an unknown number of hours as a landscaper or landscaping. And we also know that your total earnings were $400 for that week. From here, we're simply going to use the different strategies that we've been discussing. Subtract $262.50. Remember, when you subtract $262.50 from 400, you need to line up your decimal points, use your calculator, and we get 11x is equal to $137.50. So that 11x equals $137.50 is your landscaping earnings. And if we divide both sides by 11, which is how much you make per hour, we're going to find that you worked a total of 12.5 hours. So you worked 12.5 hours at the landscaping job, added to your $262.50 from the gas station, will give you a total of $400. Now the problem also asks us to check that the units on each side of the equation balance. Well, what do they mean by that? Well, at the gas station you had $30, so you'll have dollars, and times $8.75 per hour, so you have dollars. Sorry for the screen moving around. I'm going to take that all back. We work 30 hours. So we work 30 hours. So we have hours times dollars per hour, so that the hours cancel to leave us with dollars, and this is our gas station earnings. Then we're going to add that to our landscaping earnings, which is $11 per hour times X hours. Once again, canceling, and we get a remainder of a result of dollars from landscaping, and our total was $400. So we can see from this that the units of measure on the left and the units of measure on the right balance. And you recall that this is an important thing that we are trying to, an important topic that we are working with in this chapter, is seeing how units of measure can help us understand problems, set up equations, and also check to make sure that our equations are giving us the right results. And we'll end this video here.